Lesson 3.7 is officially titled Transformations of Polynomial Functions. There's basically two pieces to it. One is the transformations. And when we talk about those transformations, remember that list of transformations we've had a couple of different times this year, where when graphs move left, right, up, down, stretch, shrink, reflect, all that fun business? We're going to talk about that, specifically with two special functions. And then we're also, which this is the front set of notes, going to talk about what it means to be an even function versus what it means to be an odd function. And I will tell you it's not just whether it has even numbers or odd numbers. Okay, there's more to it than that. So, a little bit of information up here before we get into examples. An even function. You can tell a function is even or odd one of two ways. One, by looking at the graph. In my opinion, that's easiest. If you have a graph to look at, if a function is even, it's symmetric about the y-axis. The y-axis being the vertical axis, and so it's the same left and right, right? I can take a graph, fold it on that y-axis in the middle, it's the same on both sides. So a graph is even if it's symmetric about the y-axis. Or, if we don't have a picture to look at, and we just have an equation to look at, then we will want to look to see if f of x, the given function, is equal to f of negative x. And I know that means nothing to you right now, but I will demonstrate that at the bottom of this page and help it make sense. Okay? But that's the information of how we know if a function is even. As opposed to, how do we know if a function is odd? Well, again, your graph is going to be the easiest way to see, and that is if your graph is symmetric about the origin. Do we know what the origin is? What's the origin? 0, 0. Okay. In case that vocabulary word is leaving your brain right now. Okay. So symmetric about the origin. I used to say it's a double reflection. So like, for instance, if I look at what's in quadrant 1, if I reflect it across the x-axis, so it's upside down, and then I reflect that piece across the y-axis, it lands on top of what's in quadrant 3 over here. Okay? Are you being buzzed back there?
There's a fire limit on my desk. It's crawling around.
Okay, so one option for symmetric about the origin is it's a double reflection. The other option, which is what you can see by this blue arrow here, it's a rotation of 180 degrees. So if we take this graph, so like if you take quadrant 1 and you rotate it 180 degrees, which is halfway around a circle, right? If you take this and rotate it 180 degrees, notice it's going to land right down here on top of itself, isn't it? So that's what it means to be symmetric about the origin. And in fact, I'm going to put here rotation of 180 degrees, because that might help you to understand that one as well. Okay? If you don't have a graph to look at, and you have to go by algebra, then f of negative x equals negative f of x. And again, that's doing the algebra. We put the negative x in place of x versus multiplying the whole thing by a negative. Again, I'll demonstrate. I'm not going to try and explain that too much until I'm ready to demonstrate. The third option. A graph could be even, a graph could be odd, or you could fit into neither of those categories. So neither of those categories, it's not symmetric about the y, it's not symmetric about the origin. Here's an example. If this graph was placed differently, it could be symmetric about the origin, but it's not centered at the origin. And so it's not symmetric about the y, it's not symmetric about the origin, it's neither. Okay? So we're going to look at some examples of both types. Now, we're going to start off easy, looking at the graphs. So you need to look at each graph. If it's asking if it is even or odd, is it symmetric about the y-axis? Or is it symmetric about the origin? Or maybe neither. So A, what are your thoughts on that graph? What do you think, Stetson?
It's odd.
Why?
I think it's odd.
Why?
Oh, because if you rotate it 100 degrees, it'll still be on the origin.
Okay. If I take this graph and rotate it 180 degrees, right? If I take what's in quadrant 1 and I rotate it, it's going to land on top of itself down here, right? Or basically, take your paper, turn it upside down. Does it still look the same?
Yes.
Yeah. The rest of your paper looks upside down, but that graph should look the same. So this is an example of a graph that is odd. And why was it odd? Because it's symmetric about the origin. You don't even have to explain, I don't think, on homework or anything. It's just even, odd, or neither. I'm just putting an explanation down for the benefit of us. Okay, what about example B? Why even?
Because it's centered through the y-axis.
Yeah. If I take my paper and I fold it at that y-axis, both sides are going to land on top of each other, right? It's identical on both sides. So this is an example that is even. And why is it even? Because it's symmetric about the y-axis. Okay, what about C? Neither? It's definitely not even, right? Definitely not a fold in half type graph vertically. No way, no how. Why is it not odd? Yeah. If this was placed differently, could it be odd? Yeah. If this graph was brought down here and centered at 0, 0, then it would be a type graph that is symmetric about the origin. But because it's not centered there, this is an example of neither. Okay. Example D. What do you say? Odd. You can rotate it 180, you can rotate it upside down, it's going to look the same, yes? Okay. It's an example of odd. Symmetric about the origin. And what about E? Even. Even though it's upside down, right? You can still fold it in half. Okay. So you can fold that in half vertically and it works. So this is even. Because it is symmetric about the y-axis. Okay. Questions on that part? A little bit of a relief compared to last lesson, I hope. It's easier to teach than last lesson. Okay. Bottom part here. If I had to answer the question of what's the hardest part of the lesson that we're going to do today, I think this is probably the hardest part. I'm not saying it's incredibly difficult, but I think, it's a little bit hard to understand at times. So this is probably our hardest part. I think we get to the back side, and I think it will be okay. Although I will say I didn't teach the bottom of the back side, but I still think it will be doable. Is the function even, odd, or neither? Except the difference is, I just have an equation. I don't have a graph to look at. And no, I'm not saying grab Desmos and graph it. Technically, could you as a check, though? On homework, yes. On a quiz or test, no, because you're not going to have access to Desmos. Okay? So this is one where we have to be able to look at the equation. Now, so we're going to start, we'll test, what I always do is I test even, and then I test odd. And if it fails both tests, then that just puts me into the category of neither. Now, I know it's up at the top of your notes, but I'm going to write it here so I have it. What's my even rule? If f of x equals f of negative x. That's my even rule. What are we provided? We're provided f of x. So the first thing we need to do is we need to find f of negative x. So, in order to find f of negative x, every place I see n x, we're going to replace it with negative x. So right here, this is 4 times x to the 4th. So I'm going to say it's 4 times negative x raised to the 4th. And then plus 5. Now, as we clean that up, this is where you have to know, okay, what is negative x raised to the 4th? So in other words, what is a negative raised to the 4th power? A positive, right? Because when you multiply an even number, 4 is even, right? The number 4. When you multiply an even number of negatives, you get a positive. When you multiply an odd number of negatives, you get a negative, right? That's a fact we need to know. So negative x to the 4th is just going to become positive x to the 4th. Multiply the 4 back on, and it's 4x to the 4th plus 5. What do you notice here? F of x was 4x to the 4th plus 5. What's f of negative x? 4x to the 4th plus 5. Are they equal? Yes. We just showed that f of x is equivalent to f of negative x. And which rule does that follow? Even. So if you were to go and graph this, it would be symmetric across the y-axis. Okay, and that's a way you can check yourself when you're doing this for homework, review, whatever. Just don't land on the board, please. Okay. Ready to try B? And because we found it's even, we stop there, we're done. Okay, so B. This time it's g of x equals 2x cubed plus 3x. We're going to start with the same thing. We're going to test and see, is it even? So that means I need to find g of negative x. Every place I put n, or I see n, x, replace it with negative x. So 2 times negative x to the 3rd plus 3 times negative x. Clean it up and see what we have. Negative x raised to the 3rd. It's going to be a negative, right? So negative x to the 3rd times that 2 is going to make it a negative 2x cubed. 3 times negative x is minus 3x. What do I know right now? Okay. You guys understand what she's saying? We just got 2x cubed plus 3x. This is negative 2x cubed minus 3x. G of x and g of negative x are not equal, so this is not necessarily. We can't assume odd. We just know for sure right now it is not even. Okay, so I think what I'm going to write in here, g of x does not equal g of negative x, and so I know this is not even. Okay? So now, if it's not even, we've then got to check odd. Okay? From above, what's my odd rule? My odd rule, f of negative x, which didn't I just find f of negative x? And we now need to see if it's equal to negative f of x. Okay, so now I'm going to find, it's g in this case, negative g of x. So negative g of x says I'm going to take the original g, so go back to the original and multiply by a negative. So I'm going to put it out front right now. Negative times my original g was 2x cubed plus 3x. When it says negative g, that means I multiply every term by a negative. So that means negative g of x is going to be negative 2x cubed minus 3x. So I multiplied each term by a negative. What do you see? Negative 2x cubed minus 3x, what's it the same as?
Oh, that. Okay.
Here's the deal. We're not asking is it the same as the original. We're asking is it the same as g of negative x. So we're looking g of negative x we found right there and negative g of x. What do you notice about those two? They are the same, aren't they? Negative 2x cubed minus 3x, negative 2x cubed minus 3x. So what's that mean? It's odd. G of negative x ended up equaling negative g of x. And because that happened, I know this is odd. Okay. It's not that this is super hard, but there's usually a little bit of problem understanding exactly how to deal with all the negatives. Questions? Okay. Ready to try C? Okay. I'm always going to go in the same order. Because since even uses the original in f of negative x, that's the easiest thing to test for. And then odd uses that same f of negative x and a new one. So that's why I always go in this order. So they provide f of x, f of negative x. Every place I see an x, it becomes a negative x. So 7 times negative x to the fifth minus 2 times negative x to the second plus 4. Okay. With that in mind, are you catching on to how these exponents work? Since this is a negative raised to an odd, it's going to be a negative. Your sign's going to change, basically. So this is going to be negative 7x to the fifth. Now, negative x to the second is going to be a positive times the negative 2 that's already there. Means it's going to stay negative 2x squared. And then plus 4 has nothing changing it. Okay? So you put those negatives in. If it's an odd power, it's going to change whatever sign was already there. If it's an even power, it's just going to keep it the same. Okay, what do we know at this point?
It's not equal to the
Okay. What we just found is not equal to the original. Valid point. So if f of x is not equal to f of negative x, what's my brain telling me? This is not even. And to be honest, do you have to write that statement out that I just wrote out? No, I'm doing that as a teaching thing. Okay? If this was just me working on my own, I'd find f of negative x and then I'd just keep moving on. But right now it tells me not even. So, found f of negative x. What else do I need to test oddness? Negative f of x. So negative f of x says I multiply the equation by a negative. Which equation? The original. So 7x to the fifth minus 2x squared plus 4. And you may not even write the step down I just wrote. You might jump straight to the final answer. Multiplying the whole equation by a negative just means change every sign. So negative 7x to the fifth plus 2x squared minus 4. What do we know now? Negative 7x to the fifth plus 2x squared minus 4. Does it equal negative 7x to the fifth minus 2x squared plus 4? No. Two of those three signs are wrong, aren't they? So we just now discovered that f of negative x does not equal negative f of x. Sorry, scooting this over some. So f of negative x does not equal negative f of x. So my brain is saying not odd. Well, if it's not odd and it's not even, process of elimination, it's neither. So earlier when Stetson said, oh, it's not even, I know it's odd. Not necessarily, because you do have that neither option. Okay, so those are the three different possible types of examples you can see there. Okay. Have you looked at D? First, I'm going to find f of negative x. So every place I see an x, I'm putting in negative x. So instead of x to the sixth, negative x to the sixth. What is negative x to the sixth? Positive x to the sixth. Still minus 2. What do we know?
It's equal to the original.
Is it equal? It is, isn't it? X to the 6 minus 2, x to the 6 minus 2. So we just showed that f of x equals f of negative x. And since I showed that, I know that this is even. Okay. Ready to talk about transformations? And you're welcome. I didn't put them on here, but a couple of times this year you've had lists of transformations in your notes and on formula pages, right? So you are welcome to pull those back out, and I can pull out some of the formula pages too. Or maybe you know them well enough you don't need them right now. But we are, in the top part, they're going to give us an equation. And we're being asked, how does the given graph differ from the graph of its parent function? So we're looking at the transformation. So I'm going to start by drawing your attention to the middle of the page. Okay. In the middle of the page, I guess I forgot to take them off last time, but we've got two big functions we've talked about. And these are on the front page too. I don't know if you noticed that or not, but these are on the front page too, in terms of this is like what those graphs look like. The cubic function. The cubic function is y equals x to the third. And the basic cubic function looks like this. Okay? We saw a couple of those on the front. Specifically, I put a couple of dots or points here indicating that the basic cubic function, before anything's done to it, goes through 0, 0, 1, 1, and negative 1, negative 1. And the next points are like 2, 8, and negative 2, negative 8. So I didn't worry about those. But the other basic parent function we're talking about today is the quartic function. The quartic function is x to the 4th. And it kind of looks like a parabola in a way, except it's flatter at the bottom and goes up steeper. Okay? It has a point at 0, 0. And just like a parabola, from that vertex, it goes over 1, up 1. So there's a point at 1, 1, and a point at -1, +1. Okay, those are the two basic functions we're talking about today. Now, on the top part, you don't really have to know what they look like. Just know that those are the two we're talking about. As we look at A, g of x equals 3x to the fourth minus 18. The parent function that we're talking about in this case is the x to the fourth. What I need you to tell me are what are the 3 and 18 doing to it? Because they're going to take that x to the fourth graph here, and they're going to alter it. Right? Any remembrances of what that 3 or 18 does to that graph?
Could you use y equals mx plus b? Or without
No, because it's not x to the first. Okay. Down 18. Yes? No? Does that ring any bells? Why down 18? A number added or subtracted at the end will move the graph up or down the direction of the sign. This is on the notes. I think it's is it plus and minus k? Is that what it is there?
It's f of x plus c.
Okay, plus or minus c. Okay. Sorry, sometimes it's k, sometimes it's c. So they pulled out a blue formula sheet. I think it was on a half sheet of green paper. I don't know if anyone say that one or if I have all those, but we've seen it a couple of times too. So the minus 18 is going to be down 18. We're gonna write this out in a paragraph here in a moment. Okay. So now it's the question, what's that 3 do out front? Sounds right word. Vertical stretch. Okay. So when a number multiplies out front, it's either a stretch or a shrink. When the number is larger than 1, it is a stretch. If the number is between 0 and 1, it is a shrink. Or, okay, is it compression in our book? Sorry. When I say shrink, compression, some of my curriculum uses the word shrink. Some of it uses the word compression. I go back and forth because I can never remember which book I'm in and just realize they're the same. Okay. Regardless, this is a vertical stretch. That's what you need to be able to identify for that. We've done this, right? Lots of times. Except we did more with parabolas and absolute values and stuff. So I'm going to write this out in words. And I am going to mention what my parent function is. So in this case, my parent function is x to the fourth. So I'm going to say the function y equals x to the fourth has a vertical stretch. Don't forget to say the factor. So a vertical stretch by a factor of 3. So the function y equals x to the fourth has a vertical stretch by a factor of 3. And what's that word for down that I like? Translation? Translate? Okay. So is translated down 18. And is translated down 18 units, if I want to be fancy here. Okay, that's my official formal, I mean, obviously I'm looking for something about vertical stretch by factor of 3, and I'm looking for something about translated down 18 units, right? Those are the big pieces. Well, B when you're ready. Can you tell me what parent function this graph is before we get into it? Do you see how it's x cubed? Here's my x, and what's the power on that? X cubed. So this is going to be a cubic. What you have to be able to tell me are what jobs the 5, 2, and 4 have. Volunteers for any of those pieces? What do you got, Katie? Okay. There's a +4 at the end. And so that's going to be up or down the direction of the sign. So up 4. Good. Okay. The number multiplied out front is a stretch or compression, I guess I should say. Stretch, shrink, compression. It's bigger than 1, so we're stretching. Now the one we have to go for that we haven't talked about yet today. What'd you say? I agree, right 2. Does that ring a bell? When the number is in the parentheses, in the absolute value, in the square root, when it's in with the x, left or right, opposite the sign. I've said that a lot this year, right? That phrase should be familiar in your head. So this is going to be a right 2. Put it in words and we're good to go. The function y equals x cubed has a vertical stretch by a factor of 5 and is translated right 2 and up 4 units. Okay. You got the knowledge? One more. C. What are the pieces you see here? What do you see? Okay. So a 2 out front tells me we are stretching. Vertical stretch. What else? Okay. Add or subtract 5 at the end. It's not in parentheses with the x. Is up or down. So this is down 5. What's my parent function? Yeah, x to the third. Y equals x to the third. Okay. Put it in words and you're good. The function y equals x cubed has a vertical stretch by a factor of 2 and is translated down 5 units. Okay. On the bottom part of this, which is the same thing that happened this morning. I technically could get through part of the bottom of this, but I wouldn't be able to get comfortably through it. I'd be rushing. So I'm going to save the bottom part for Monday. Okay. But the bottom part, notice they give you a graph, right? Our job is to take the graph, look at the pieces happening, and write the equation for it. So, if we see a down 18, no, we have to put a minus 18 in the equation. If we see a right 2, no, we have to have a x minus 2. Things like that. So we're going to do that on Monday. You should have some work time then. And right now, the homework's officially listed as due on Monday. That's because you're supposed to have started it yesterday. Okay? I may still leave it due on Monday. I'll see how much work time we have and stuff. But that due on Monday would be at night. So we'll see. I might change it too. So I don't know.